Most people assume the biggest problem with electric cars is range. They are wrong. Range was solved years ago. The number that actually determines whether someone buys an electric car or stays at the gas pump is not how far it goes. It is how long it takes to charge when it is almost empty, and what happens to the battery 10 years down the road. That is the calculation people do in their heads every time they pass a charging station. And for most of the last decade, that calculation has not added up. But something happened on the 5th of March, 2026, in Shenzhen, China, that changes the math permanently. And there is one specific number from that event, one number that BYD printed in writing, that the rest of the car industry does not want you to focus on. We will get to that number, and once you hear it, the conversation about electric cars is never the same again. Here is what you need to understand first. The fears keeping Americans in gas cars are not irrational. They are based on arithmetic. Pull up to a gas station, and the transaction takes 5 minutes. A standard mid-size EV connected to a typical 150 kilowatt DC fast charger, which is the kind most commonly found along American highways, needs roughly 45 to 68 minutes to go from near empty to road ready. The average American lives 4 minutes from a gas station and about 30 minutes from the nearest DC fast charger. That is not a minor inconvenience. That is a structural problem with how daily life is organized. And then there is the other fear, the quieter one that no EV commercial ever addresses directly. What happens to the battery? A replacement EV battery pack in 2025 runs anywhere from $8,000 to $15,000 for a mainstream crossover, and from $15,000 to $25,000 for a larger truck or luxury sedan. A $12,000 repair on a $22,000 used car does not feel like a calculated risk. It feels like a trap. Those fears are real. They have real numbers behind them. The question is whether one company just made both of them obsolete simultaneously. That company is BYD. And if you have heard of BYD at all, you probably think of it as a Chinese car brand trying to break into Western markets. That framing is about 30 years out of date. To understand why what happened in March 2026 matters, you have to understand who actually built it, because this is not a startup with a PowerPoint presentation. This is a company built from the ground up around one obsession, and that obsession has been running at full intensity for 3 decades. In February 1995, a 29-year-old chemist named Wang Chuanfu borrowed the equivalent of about $30,000 from his cousin and started a small battery company in Shenzhen. Wang had grown up in rural poverty in Anhui province, orphaned as a teenager, raised by his elder brother and sister. He had studied metallurgical chemistry, noticed that Japanese manufacturers were abandoning nickel-cadmium battery production, and saw a window. He named the company Build Your Dreams. He had no factory full of robots, no government contract to start, no inheritance. What he had was a more thorough understanding of battery chemistry than the companies he was competing against. He used a labor-intensive manufacturing approach to undercut Japanese suppliers on cost without sacrificing quality. It worked. By the early 2000s, BYD was one of the largest battery manufacturers in the world, supplying Nokia, Motorola, and others. But Wang was already thinking bigger. In 2003, he acquired a struggling automobile manufacturer nobody respected and announced he was going to make electric cars. The reaction in the industry was somewhere between dismissal and laughter. Warren Buffett did not laugh. In 2008, Berkshire Hathaway invested $230 million in BYD. Charlie Munger, who pushed Buffett toward that investment, later told Fortune magazine that Wang Chuanfu was a combination of Thomas Edison and Jack Welch. That is not the kind of endorsement you forget. By 2025, the company that started with a $30,000 loan from a cousin had become the world's largest electric vehicle manufacturer, surpassing Tesla in total battery electric vehicle sales. BYD reported revenues of roughly $106 billion in 2024. Its subsidiary FinDreams Battery held a 17% share of the global EV battery market, second only to CATL. TL.use. The reason that background matters is this. When BYD announced something new in March 2026, it was not a press release from a company trying to generate headlines. It was the product of 30 years of uninterrupted obsession with battery chemistry. That context changes how you listen to what they said. The 5th of March, 2026. BYD's disruptive technology event in Shenzhen. Wang Chuanfu took the stage and introduced the second generation of the Blade battery alongside a new charging infrastructure called flash charging. The specifications started coming in waves, and each one was more aggressive than the last. Start with the charging speed, because that is the wall most people hit first. The first generation Blade battery, which was already considered competitive, took about 33 minutes to go from 10% to 80% charge. The Blade Battery 2, paired with BYD's 1,500 kilowatt flash chargers, goes from 10% to 70% in 5 minutes, not to 50%. Not with special conditions. From 10 to 70 inches the time it takes to use the restroom at a highway rest stop. The full charge from 10% to 97% takes 9 minutes. And here is the detail that the cold weather skeptics always reach for. Even at -30 degrees Celsius, conditions that typically devastate charging speed in conventional lithium-ion batteries, the Blade Battery 2.0 goes from 20% to 97% in 12 minutes. That is only 3 minutes slower than at room temperature. That cold weather performance alone is a leap that no other mass-production battery has achieved. The range numbers came next. The second-generation Blade battery achieves over 1,000 kilometers under Chinese CLTC testing conditions, which translates to roughly 620 miles. The CLTC standard is more optimistic than the EPA testing cycle Americans use, so a real-world EPA equivalent figure would be lower, probably in the range of 400 to 450 miles on a full charge for the best-equipped models. That is still more than the vast majority of electric vehicles currently sold anywhere. The Yangwang U7, the first production vehicle to receive the Blade Battery 2, is rated at 1,006 kilometers under CLTC. The Denza Z9 GT reaches 1,036 kilometers under the same conditions. Now here is the number that changes the industry conversation. The number BYD printed in the warranty. BYD has guaranteed that the Blade Battery 2 will remain functional across a battery life of 1.2 million kilometers. That is 745,000 miles. Read that again, slowly. 745,000 miles. The average American drives about 12,000 to 15,000 miles per year. At that rate, this battery is warranted for something between 50 and 60 years of typical driving. Which means, in practical terms, BYD is not guaranteeing the battery will outlast a normal ownership period. They are guaranteeing it will outlast the car. Multiple times over. For a decade, the central objection to buying an electric vehicle has been, what happens to the battery? The fear of a 5-figure replacement bill sitting somewhere in the future, silently ticking. BYD just answered that question with a document. Not a marketing claim. A written warranty. That is a fundamentally different type of statement, because warranties have legal and financial consequences if they are not honored. The technical foundation behind these numbers is where the story gets genuinely interesting, because BYD did not simply make a bigger battery, they rebuilt the chemistry from the ground up. The first-generation Blade battery used a standard lithium iron phosphate cathode with a graphite anode, solid, proven, safe, but with known limitations on both energy density and charging speed. The Blade Battery 2 upgrades the cathode to lithium manganese iron phosphate, which raises the operating voltage from 3.2 volts to 3.8 volts. That voltage increase is what enables higher energy density without proportionally increasing the physical size of the pack. The anode switches from pure graphite to a silicon-carbon composite, which has a significantly higher lithium storage capacity than graphite alone, and the electrolyte is reformulated with what BYD calls a flash pass ion transport system, an AI-optimized chemistry designed to maximize how quickly lithium ions move through the battery during charging. Here is the piece that most reporting on this technology glosses over, and it is the most important part technically. The enemy of fast charging is not power, it is heat and the SEI layer. The solid electrolyte interphase layer forms on the surface of the anode during the first charge cycles. In conventional batteries, rapid charging causes uneven lithium deposition on that layer, a process called lithium plating, which degrades capacity and in extreme cases creates internal short circuits. BYD's engineering team redesigned the SEI layer at the molecular level, making it simultaneously thinner, which increases ionic conductivity, and denser, which ensures chemical stability. They then added what they call dynamic self-repairing technology to maintain that structure through repeated high-rate charge cycles. The result is a battery that BYD claims maintains over 3,000 charge cycles at extreme charging speeds, without the degradation curve that has historically made fast charging incompatible with long battery life. To prove the point, the company ran a simultaneous flash charging and nail penetration test on the battery. 500 consecutive flash charging cycles followed immediately by driving a nail through the cell. No thermal runaway, no smoke, no fire. That test does not exist anywhere else in the mass production EV industry. This is the point where the channel's central idea applies directly to this story, because here is what every major automaker in America and Europe has spent the last decade doing while BYD was doing this. They have been managing battery anxiety with marketing, range numbers calculated on optimistic test cycles, warranty terms with fine print that protect the manufacturer more than the owner, charging networks that are technically impressive on paper but unreliable in practice. The strategy of American and European automakers has been to make the battery good enough for the segment they were targeting, because good enough is cheaper to engineer than exceptional, and exceptional is a competitive problem if you achieve it too early. The product lives exactly as long as the warranty requires it to, and then the customer buys another one. That is not a conspiracy, that is arithmetic. If the battery lasts 8 years, the customer either buys a new car or pays for a replacement pack. Either way, revenue continues. A battery warranted for 745,000 miles is a direct attack on that model. It is a company saying explicitly, our product will not be your recurring cost. And BYD built the infrastructure to make this practical, because a fast-charging battery is useless without fast chargers. As of the 5th of March, 2026, BYD had already deployed 4,239 flash charging stations across China. The plan calls for 20,000 stations operational by end of 2026, including 2,000 on highways spaced approximately every 62 miles. Each station uses a T-shaped overhead design with liquid-cooled cables that the company says eliminates the cable damage and connector contamination that frustrates users at conventional public charging stations. More importantly, each flash station is paired with an on-site battery energy storage system. That system draws power from the grid slowly at off-peak rates, stores it, and then discharges it at up to 1,500 kilowatts when a vehicle is charging. This is the technical answer to the grid collapse objection, the concern that mass adoption of megawatt-level charging would overload local electrical infrastructure. The storage buffer absorbs the grid-level impact. The car gets the speed. The utility does not see a spike. For context on what 1,500 kilowatts actually means, Tesla's V4 superchargers, which are currently the fastest widely deployed chargers in the United States, operate at 400 volts. BYD's flash charging infrastructure runs at 1,000 volts. At full output, BYD's system can add 400 kilometers, roughly 250 miles of range, in 5 minutes. The charging speed BYD is deploying is not incrementally better than what exists in America. It is in a different category. The company is not stopping with passenger cars, and this is where the scale of what is happening becomes visible. The same blade battery 2 chemistry applies to SUVs, commercial trucks, buses, and grid-scale energy storage. BYD has confirmed plans for over 3,000 flash charging stations across Europe by end of 2026. Tesla, which BYD surpassed in global EV sales, purchased first-generation Blade battery cells from BYD's FinDreams subsidiary for Model Y production in its Berlin factory. The benchmark bought cells from the underdog. Meanwhile, CATL, the world's largest battery producer, responded to the March 2026 announcement by accelerating its own third-generation fast-charging platform, which launched in April 2026 with a rated full charge time of under 7 minutes. The battery arms race is no longer theoretical. It is happening in production vehicles, on public roads, right now. BYD has also announced that solid-state battery production, which represents the next generation beyond what the Blade Battery 2 achieves with liquid electrolyte chemistry, will begin in limited production in 2027, with mass production targeted for 2030. Solid-state batteries eliminate the liquid electrolyte entirely, replacing it with a solid ceramic or polymer material that is more stable at high temperatures and theoretically allows even higher energy densities and faster charging. The Blade Battery 2 is not the destination, it is the bridge. So, what does this mean for someone buying a car in America right now? BYD does not currently sell passenger cars in the United States. The company has explicitly stated it is not planning to enter the U.S. passenger vehicle market in the near term, citing political and tariff conditions. But the pressure this technology creates does not require BYD to be at your local dealership. Every American automaker watched the March 2026 announcement. Every battery supplier received the memo. When a competitor demonstrates that a 745,000-mile battery warranty is achievable in mass production, and that charging from near empty to road ready takes 9 minutes, the bar has been publicly set. Manufacturers who do not match it have to explain to buyers why their product cannot. That is competitive pressure without a single car crossing the Pacific. The consequence for American consumers is this: a battery warranted for 745,000 miles is not a selling point in isolation. It is a signal about the entire economic structure of owning an electric car. The calculation has been: buy the car, manage the range anxiety, hope the battery makes it past the warranty, and budget for a potential 5-figure repair in year 9 or 10. That calculation was priced into every used EV on the market. It was priced into every hesitation at the dealership. BYD just printed a number that says the battery outlives the car, and that changes what you should be willing to pay for any other battery technology that does not offer the same guarantee. Here is what to take from this if you are paying attention. Buy chemistry, not brand. The shift from standard LFP to LMFP cathode chemistry with a silicon-carbon anode is the specific technical advancement that enables both the 745,000-mile lifespan and the 9-minute charge. Any battery using older graphite anode LFP chemistry from 5 years ago is operating in a different performance category, regardless of what the marketing materials say. When evaluating an EV purchase, the warranty is not fine print. It is a specification. A company that cannot offer a decade-plus battery guarantee with a documented state of health floor is telling you something about what they believe their battery will do over time. And the infrastructure matters as much as the battery. A 9-minute charge is theoretical if the only charger within 30 miles is a 50-kilowatt level 2 unit at a hotel parking lot. The battery technology and the charging network have to scale together, which is why BYD built both simultaneously rather than announcing one and hoping the other catches up. The man who started with a $30,000 loan and a thorough understanding of battery chemistry just signed a document guaranteeing his battery will outlast any car it is installed in. That is not a marketing claim. That is a warranty. And a warranty is a bet. The question every other automaker is now asking behind closed doors is whether they are capable of making the same bet. Most of them are not ready to answer yet, but BYD already answered, in writing, on the 5th of March, 2026, in Shenzhen. If this analysis changed how you think about the battery industry, subscribe. Every week we go deeper into the technology and economics that the headlines flatten into noise. This is exactly the kind of story that disappears from the front page in 48 hours. It should not.